Yesterday we looked at a bunch of properties of these higher degree polynomials. So today we're going to kind of take some time and review those properties so that we really get them down. So the warm-up, is this an even or odd degree function? Well, it's a smiley face one, so we know that they end the same here. So this would be an even degree function. Degree, let's count the number of turning points. So it changes direction 3 times, so this could be a degree 4 graph. Is the lead coefficient positive or negative? Well, since the ends end up, we know that the lead coefficient is positive. So we're going to review all these properties today and look at one more. So to review, degree is the highest power. So for example, the degree of this one right here is 5. The degree of this one right here is 3. Degree 5, degree 3. The lead coefficient is the number in front of the exponent with the highest power. So here this is a positive lead coefficient of 3. Here this is a negative lead coefficient of negative 1. A lead coefficient of negative 1. Let's look at even versus odd degree. So we know that if they're even degree functions, they're smiley face or field goal functions, I call them. So they end the same way, either up or they end going down. The odd degree functions I call the bendy straw functions. So either you're drinking up the straw or your liquid is leaving the straw. Okay, so if they end the same, they're even. And if they end differently, like a bendy straw, up and down, it's an odd function. All right, what does a positive or negative lead coefficient tell you about the graph? Well, for these even functions, if you have a positive lead coefficient, it's going to end up. And if you have a negative lead coefficient, it'll be like a frowny face graph. So it could look something, well, it has too many turning points. It could look something like that. For your odd degree functions, if you have a positive lead coefficient, you like what you're drinking, you could drink up the straw. But if the first one's negative, that liquid might be leaving your straw. Okay, so an odd one starts low, goes high, that has a positive coefficient. If it has a negative lead coefficient, you start high and you go low. And then we also talked about end behavior. As you go to the left, what's happening to your graph? As you go to the right, what's happening? So let's do that for these two examples. Let's look at the left-hand behavior first. So as we go to the left, our graph is increasing. As we go to the right, our graph is decreasing. So our right-hand behavior is decreasing. All right, let's do the next one. Again, as we go to the left, here's the left-hand side. This is increasing. And then as we go to the right, it's also increasing. Okay, so there's end behavior, what's happening in the graph, increasing or decreasing as you go to the left or the right. Last thing we looked at is the number of turning points. The rule is it's one less than the number of zeros. All right, the degree. So this would be an x squared as the highest power, because that's one turning point. This has 3 turning points, so it's x to the 4th. This has 4 turning points, so x to the 5th. You can take a look at field goal or bendy straw functions. So these are field goal functions because they end the same way.
Lauren, please call 6102. Lauren, please call 6102.
So again, I call these field goal functions. You can call them smiley face functions too. And this one is a bendy straw function. We can call it BS, right? Bendy straw. Because it starts low and goes high. Okay. So the last thing that we're going to look at is, can you figure out when the graph will bounce off the 0 or go through? Because sometimes they bounce. So here's the first one. It's going to bounce off. Bounces off the 0. Or does it go through? So if this is a 0, here it goes through. So how can you tell when it's going to bounce or go through? So we'll look at, for examples, what do you notice about the zeros and the exponents? So let's take a look at the first one. We know that the 0 here is positive 1, and it goes through. Look at the exponent. Here, again, we know the 0 is 1. But look at the exponent. It bounced off. Let's do one with more. So here we have 2 zeros at negative 3 and at positive 1, and it goes through. So this one went through, and then this one bounced off. Called T for through and B for bounce. All right, at negative 2 it bounced. At negative 1 bounced. At negative 2 it went through, and at negative 4 it went through. Okay, so again, look at the exponents of when it bounces and when it goes through. What do you notice? You should notice that if the exponent is even, that it's going to bounce off the 0. And when the exponent is odd, it's going to go through. Okay, so let's practice this. Steps are factor. Why do we factor? So we can find the zeros. If the zero is a real number, then it will be an x-intercept. Yes, we know that from last chapter. The multiplicity, so we call this multiplicity of the zero. The multiplicity is even, so if the exponent is even, it will bounce off. And if the multiplicity, so if the exponent is odd, it will cross through. Okay, so let's do 3 examples. Find each zero and write if the zero will bounce off or cross the x-axis. So the first zero is 3. You can see that over here, 3, or just do the opposite of x minus 3. And look at the multiplicity of the exponent. The multiplicity here is 1 because it's not written, it's 1. So I'm going to write exponent is 1. And this one will go through because it's odd. And we can see it going through because it's odd over here. Okay, let's do the next one. X equals -2. Again, we factored, we know the 0 is -2 here. And look at the exponent, which is 2, which is even, and you can see it bounces off. So it bounces through the even exponents and it goes through the odd. Let's try the next one. What are the 2 zeros? Well, one of them is at 1. We can see it at 1 over here. And the multiplicity of the exponent is 2, which means it's going to bounce off. And we can see, yep, it bounces off. And then the next one, the other zero is at -4. The multiplicity of the exponent is 3, and it goes through. And we can see, yep, it does indeed go through. Okay, so even exponents, it bounces. Odd ones, it goes through. All right, the next one, oh, this one's not factored for us. We can see the zeros, but let's factor this and see how they got those zeros. So if we take a look at this, the greatest common factor is x squared. I'm going to pull out an x squared from each of those. All right, so you have x squared. Divide each by an x squared and think about what you have left. So x to the 4th divided by x squared is x squared, minus 4x squared divided by x squared is 4. Oh, look, we have difference of squares right here. We know this is x plus 2 and x minus 2. Okay, so let's talk about what the zeros are. One of them, if we just have x, what makes that 0? It's 0. So here's one of our first zeros. What's the exponent? It's 2, so this is going to bounce at 0. And you can see at 0, it bounces. Let's take a look at the other 0. So -2. What's the exponent? If it's not listed, it's 1. 1 is odd, it's going to go through. And our other 0 is +2. Again, if the exponent is not listed, it's 1. So it's going to go through the graph. So you can see at -2 it goes through, and at +2 it goes through. All right, let's go backwards. If I give you the 0 and the multiplicity, can you draw it? All right, so draw a function. It can look different than your neighbors. That meets the following requirements. All right, so here I'm going to draw in my zeros. So at -6 there's a 0, at -4 there's a 0, at 0, at 4, and at 7. So here are all the zeros. And you can pick where you want to start, but we know that if the multiplicity is 3, it's going to go through. That just means the exponent is 3. If the multiplicity or the exponent is 2, it's going to bounce. This will be through, bounce, through. Okay, so if it's odd, it goes through, even it bounces. All right, so let's try drawing this. You can either start above or below. I'll start above. So it's going to go through, it's going to bounce, it's going to go through, it's going to bounce, and it's going to go through. So here's just one way I could have drawn it. I could have gone the opposite way as well. So let's do an opposite one. I'm going to erase this. Okay, the other way that I could have drawn it, I'll just keep the same color. Could have started down here, gone through, bounced, gone through, it's going to bounce, and it goes through. So here's another function that you could have drawn. Looks a little funny. But again, you have to know if it's an even degree, the multiplicity is even, it's going to bounce and odd goes through. All right, so give this a shot. Review those properties of exponents, and now you have that multiplicity to look at as well.